Hello and welcome to our October Globe Observer Connect session. The purpose of these sessions is to have a chance to talk to subject matter experts about globe or globe connected topics and just have a conversation, ask some questions, get a chance to learn a little bit more about some of these topics. We are recording this session, so if you don't wish to have your video on camera, your picture on camera, please turn off your video. You can ask questions in the Q&A and we can read them aloud. But if you prefer, if you want to ask them yourself, you're certainly welcome to do so. But just be aware that this is being recorded and we will post this up on our website. So I guess I should introduce myself. My name is Kristen Weaver. I am the Deputy Coordinator for the Globe Observer Citizen Science app. And we're joined here this evening by MaryKay Severino. She and I are kind of co-leading our Globe Eclipse activities. And I'm going to turn it over to her to introduce our guest experts for this evening.
Awesome. Thank you, Kristen. Hello, everybody. It's eclipse time. I hope you're as excited as I am. We have some amazing speakers tonight that I can't wait for you to meet. We have Brant Dodson, who's a NASA scientist here with us at NASA Langley Research Center. And he has used the globe data in the past, so he's really excited to share about that and how he evaluated the eclipse using cloud and temperature observations. And then we have Trae Winter, MaryKay Severino from Eclipse Soundscapes and experiencing the eclipse with all of your senses. And so we're going to go through a quick overview if you didn't have a chance to read both blog posts, but the blogs are there for you to review, read through, get some details as we prepare for the first eclipse, which will be next weekend. Oh my goodness. So without further ado, I'm going to pass it to Brant. So Brant, there you go.
Hey everyone, my name is Brant Dodson. I'm an atmospheric scientist at NASA Langley, as well as the president of the Skywatchers Astronomy Club here at Langley. So I'd like to talk to you all a little bit about the eclipse and eclipse meteorology and all right, so just a little bit about myself. I have interest in both astronomy and in meteorology, weather and climate. I go back as far back as I can remember, at least back to preschool. I grew up in Houston, Texas, and I had opportunities to explore space. You know, the Johnson Space Center was down there. You got to go to Space Center Houston. That was a lot of fun. Houston also has a lot of thunderstorms and sometimes, you know, tropical cyclones and so on. So a lot of interesting weather down there. That really helps grow my interest in those topics. Now, when I got to college age, I had to choose one topic to focus on. And so I chose atmospheric science. But I still have my interest in astronomy, of course. So I became an amateur astronomer, and I'm continuing with that passion as well. So even though astronomy and atmospheric science are they're considered two separate fields, right? But there are many overlaps between the two, like there commonly are in science. You know, science there are discrete fields in science, but there's a lot of overlap between them. In astronomy and atmospheric science, solar eclipses are one of those events that really bring the two together. So I find them fascinating from a scientific perspective as well as from just a human perspective. So I'll talk a little bit about eclipses. All right, so this topic is a little bit interesting to me because I went in 2017. I went to go see the Great American Total Solar Eclipse. I was out in Idaho at the time with a friend, and we saw it. And it was spectacular, and so I was just going out of my interest in astronomy. But then in 2018, the people at Globe Clouds approached me and asked me about, hey, do you want to do some research about the eclipse using citizen science data? And so I found that a fascinating opportunity. So I joined with Globe Clouds to work with them and their data. And in particular, they had a special program during 2017 eclipse where they were collecting data through the Globe Observer app, temperature and cloud measurements. And so I was given the opportunity to take those measurements and do a little scientific research about eclipse meteorology. And so I had a project investigating how cloud cover affects the temperature perturbation caused by the eclipse. And so, in addition to learning about eclipse meteorology, we also learned a lot about how to use citizen science data in doing research science. And so I learned a lot. The globe clouds and the team really learned a lot about that. And so it was a really neat project that we were able to work on and, learn more about weather and climate in the process. All right, so solar eclipses, they have been studied for a long time by both astronomers and atmospheric scientists. There's a long history about this. I don't have time to get into all of it, but to summarize over a century's worth of work on this, you can think of solar eclipses as being basically a natural experiment to study meteorological processes as well as other processes on Earth. One of the difficulties in atmospheric science and other Earth sciences is that we cannot put Earth into a laboratory and experiment on it, right? It's a little difficult. So scientists, we have to make do with what nature provides us. And so solar eclipses provide us with what is pretty close to an idealized experiment about, well, what happens when you block out the sun suddenly for a short period of time, 2 or 3 hours or so. And so scientists can use the observations from solar eclipses and their effects on weather. We can see what actually happens using lots of data collected, from citizen scientists amongst other sources. And we can compare that to then what do scientists predict should happen according to our theories and our models. And then when they disagree, we can then evaluate our knowledge of the atmosphere and help improve our understanding of how weather and climate work. So there's a large number of atmospheric responses to solar eclipses. I'm just going to talk about some of the most noticeable ones and things that the general public looking at eclipses, y'all might experience this looking at the upcoming eclipse in this month and then in 2024. First one that pretty much everyone notices is there is a temperature effect associated with eclipses, right? The moon blocks the sun temporarily. The temperature decreases, usually by a few degrees Fahrenheit or so. So the cooling is strongest in the path of totality, but there is a noticeable cooling even, hundreds of miles away from the path of totality. So it's a fairly widespread effect associated with the eclipse. And also because the moon is blocking the sun, it cuts off surface heating, right? And so the temperature effect of the eclipse is felt most strongly at the surface. Something I noticed that was interesting in my work with globe clouds is that when looking at meteorological weather station data, even if you go just a few meters above the surface, there's a noticeable, the temperature decrease is smaller as you go above the surface, even just 10 meters or so above. So it's really a lot of the eclipse's effect is at the surface and, where people get to experience it. But there is a lot of variability in how much cooling there is from solar eclipses. Not all eclipses are the same, and even along the path of the same eclipse, you don't always get the same amount of cooling everywhere, even along the path of totality. And so some of our work is trying to understand what factors control that variability in the amount of temperature perturbation from the eclipse. Another effect that eclipses commonly have on weather is on clouds. So it's been noted in many eclipses, not all, but many eclipses, that as the eclipse passes, as totality arrives and leaves, oftentimes people will observe that cloud cover might decrease. In particular, low-level cumulus clouds, which are strongly affected by the heating of the Earth's surface by the sun. Well, if you cut the solar heating off, you cut off the fuel source for cumulus clouds. And so those clouds will often, not always, but often erode and maybe even dissipate during the eclipse, which is particularly nice for people there trying to watch the eclipse so that sometimes they get a better view if those clouds dissipate. But as many astronomers will tell you, that does not always happen, unfortunately. So trying to understand, well, in what conditions are clouds affected by eclipses? That's another topic of work that we need to investigate further. And so the third response, the final one that I'll touch on, is wind. Solar eclipses commonly affect, not always, again, there's a lot of variability, but eclipses commonly affect the wind. And in fact, eclipses going back many decades, have been associated with this kind of semi-mythical eclipse wind, right? When totality arrives, many people report feeling a chilly wind blowing over them. And sometimes that's recorded in the data, but not always. But we need a lot more data to figure out all the details about how that works. But scientists have identified a few different effects that eclipses have on the wind. Sometimes, during the day, the wind is gusty, right? Like during a nice spring day, like we'll hopefully have in the 2024 eclipse. Well, if during the eclipse the sun or the moon blocks the sun, that might decrease the gustiness and actually cause the wind speeds to decrease a little bit. But other times, again, depending on the conditions, the presence of the eclipse can actually cause the wind to increase or even change direction. And so there's been a lot of work by scientists trying to understand exactly how does the wind respond to eclipses. And it's tricky, right? Because there's a number of different effects that go into what controls the wind, what controls the clouds, what controls the temperature. And so there's still, even with over a century of work of eclipse meteorology, there's still a lot of work that needs to be done. We need to gather more data. And that's why these projects, like being conducted by Globe, asking citizen scientists to go out and collect a whole bunch of data, are very useful and very necessary for helping us understand eclipses and the connection between space and our atmosphere. So I think that's my last slide. So that's all I have. Thanks for listening.
Awesome. Thank you so much, Brant. I'm going to stop sharing quickly as we turn to our next presenters. Again, these are just a brief overview of the blog post that were shared. I just want to make sure that I'm also sharing audio. There you go.
Hello, everyone. My name is Dr. Trae Winter. I am the co-founder and chief scientist at ERISA Lab. ERISA stands for the Advanced Research and Inclusion and STEAM Accessibility, where STEAM stands for Science, Technology, Engineering, Arts, and Math. I'm joined here today by the other co-founder of ERISA Lab, MaryKay Severino, who serves as the education director for ERISA. And we're here to tell you a little bit about Eclipse Soundscapes and the project that we're doing to try to engage everyone in doing real and meaningful science around the eclipses. We are a NASA-sponsored citizen science project, and we're studying how eclipses impact life on Earth. So it's been known for a while, and people have told stories for a long, long time, that during eclipses, wildlife seems to change their behavior. And that makes a lot of sense, right? Because we're all primed to do different things during the day than during night. Some animals hunt during the day, some hunt during night, some try to find mates during the day, some try to find their mates during the night. And all these lead to changes in animal behavior. But these were all just stories until almost 100 years ago, when a scientist named Wheeler and his team decided to study this a little bit more scientifically. So there was an eclipse that they knew was going to happen in the Boston area in 1932. And what Wheeler decided to do was to try to engage the entire public in writing down what they observed during the eclipse, the changes that they observed, and sending all of those observations into him and his team so that they could publish a paper on it. Now, today we call that citizen science, but back then there wasn't a name for it. And we think that this is the first published experiment where a scientist actually used the power of citizen, or as we like to say, participatory science, using the public to actually be able to help scientists answer a scientific question. And when you think of citizen science, think of citizen of the world, not any one country or another. Anyone can participate in science, and that's one of the things that we really try to promote, that anyone can do science. We're trying to make it as inclusive as possible. Also, too, when all these people were reporting back what they experienced, those experiences weren't just visual. Yes, during an eclipse, day becomes like a twilight. It's very confusing to animals, but people also recorded that they heard a lot of changes. Animals change their sounds as they go from day to night. Also, too, people reported feeling temperature changes. And this is something else that people talk about a lot, that they feel it getting colder during an eclipse. And of course, this might be expected because Earth's main source of energy, the sun, is being blocked. Again, it hadn't been really recorded before then. What we're trying to do is a direct connection to that 1932 to 1935 study of eclipses that Wheeler did, but to do it in a more modern day using more modern techniques, using all the tips and tricks that we learned about how to engage the public, and also to some more modern technology. There's lots of different ways that you can participate in the Eclipse Soundscape Citizen Science Project. Again, we say that this is a multi-sensory project, so it's not just about seeing changes in the eclipse, but you can learn a lot about the health of habitats and the animals and wildlife that live in them by studying all the sounds that wildlife makes in those habitats. So we'll be doing more than one way of actually capturing those changes in sound. This picture right here shows an audio moth. An audio moth is a low-cost audio data recorder, is science grade, and we're asking people to put these out in different locations along the eclipse path and take a recording a couple of days before the eclipse, during the eclipse, and then pick them back up 2 days after the eclipse. And by using the data of the sounds that are being recorded, soundscape ecologists, people who study the sounds that animals make in different habitats and what those sounds mean for the animals, what they're doing, are they under stress, what conditions are undergoing. They will use all of that data to determine how the eclipses impact life on Earth. But that's not the only way that you can participate. There are multiple ways that you can participate. And I could tell you about all the different roles and different ways to participate, but this is how, we're trying to be inclusive. There's not just one way where you need a kit in order to participate, but there are many roles and many different ways that you can participate, whichever way works best for you. Instead of me explaining it, MaryKay Severino, our education director, made these great short videos that are up on YouTube. And I'll let MaryKay explain it via this YouTube video. So Marley, if you could play that video real quick.
Eclipse Soundscapes needs your help to collect and analyze observations and sound data from the October 14th, 2023 annular eclipse and the April 8th, 2024 total solar eclipse. There are many ways you can get involved via various roles. As an apprentice, you can learn about solar eclipses online. As a data collector, you can get outside during eclipse week and collect audio data using a special device called an audio moth. As an observer, you can get outside on eclipse day, observe with all the senses available to you, and then submit these observations online. As a data analyst, you can analyze all of the data online after the eclipses. For each of the roles you complete, you will earn a certificate. We hope you will get involved in the Eclipse Soundscapes project.
Okay, so that was a nice introduction to all of the different ways that you can participate. That video, along with others, are on our website, eclipsesoundscapes.org. There's also lots of learning materials. There are resources for classroom teachers. There are resources for librarians and community leaders that want to hold events for their groups all around the Eclipse Soundscapes project. And again, you can participate in any of the ways that you want to. And as soon as you complete each role, you can have a certificate saying that you completed that role of the NASA-sponsored Eclipse Soundscapes project. And with that, I'm going to call that good. And if you've got any information, if you have any other questions, feel free to ask us, or you can go to our website, eclipsesoundscapes.org.
Excellent. Thank you so much, everybody. Now we're going to open it up to questions. Kristen and I will go through your questions. You are free to unmute and we can call on you. So are there any questions for our speakers?
And yeah, Marley, if you want to stop sharing so we can see everybody, but just a reminder, we are recording this and it will be posted on our website. So if you don't want your image to appear as part of that recording, please turn off your camera and you can ask questions as part of the Q&A. We do have one question already in the Q&A, and the question is for Trae. How long have you been working on this project, Dr. Winter?
Well, MaryKay and I have been working on it together. It is an equal partnership between scientists and educators, which is why I think it works as well as it does. We did the first part of this project in 2017, and then we actually spun off ERISA Lab from where we were working before, just so that we could work on projects like this. And we've been working on this particular part of the project nonstop, 100% since 2021. And it has been a lot. It has been a lot of work and effort. I feel very lucky that we get to do it.
Another chat question in the Q&A. Is there any evidence of differences in temperature changes over land versus near over ocean? That may be one for Brant to take a stab at.
I think
Well,
he's
Brant's
having
coming online. I'll say that one of our colleagues in SciAc, Dr. Angela Desjardins of the National Eclipse Ballooning Project, is actually measuring temperature differences in the upper atmosphere. And there are differences detected in the upper atmosphere during the eclipse, which is very cool.
And I think as Brant's trying to get back in, I think the other thing thinking about, for example, the 2017 data is that one of the challenges is where are you able to collect the data from? If you think about the eclipse path from 2017, it can, there's a brief area over the ocean as it entered the United States, kind of, and then again as it left. But a lot of the eclipse path in 2017 was inland. So it depends. It's not like we're controlling where the eclipse is occurring and being able to choose the places where we can have the eclipse happen or not happen. So it can make it a little bit more challenging to answer some of those questions if the data isn't, if the eclipse isn't in the right place.
So being near the ocean can have an effect. It, again, like everything, is complicated, and it depends on whether you have a land breeze versus a sea breeze, right? If you're having wind from the ocean that's cooling and moderating things, that can affect how much of a temperature decrease that you get. But I don't think it's absolutely guaranteed that you're going to get like a smaller decrease if you're near ocean.
Well, and I think there are a lot of factors that go into these temperature changes, because It's not just the eclipse, of course, it's all the other factors that are always influencing the weather, which can mean that it can be a little challenging to pull out exactly what's the eclipse effect versus what is just, the things happening during the weather that day. Although we do have a comment from Holly in the chat that she's experienced 2 eclipses, one on an ocean beach and one inland. She definitely noticed a bigger temperature change near the beach. There could have been a lot of other things at play. John, go ahead and ask your question, and then we'll go back to the other one in the Q&A.
Okay, great. Hi, everybody. I just had a really quick question on, like, from the 2017 eclipse to the one that we're going to experience this month. Was there, I don't remember seeing anything regarding an urban heat island kind of analysis of taking a look at that, how that also looks at, as far as, like, I understand there's like the land cover that's going to be included for this eclipse protocol that's coming up, was great and everything, but is there going to be like a more detailed look at that urban heat island, especially because, desert versus somebody up further north and more green versus somebody that's out in the ocean? I'm pretty sure those are going to be different kind of results that you would actually get. But are there going to be anything similar to a more in-depth kind of analysis of that, not only just looking at the air temperatures, but are we also looking at those type of things that contribute to that urban heat island effect?
I don't recall off the top of my head if there's any like particular, how much focus there's been in particular on like urban heat island effect. There has been a lot of focus. There has been people looking at, well, if you're over like concrete, like I think has been come up before, you get more of an effect than if you're, over grass in an open field or something like that. So, but yes, what surface type you're on can have an effect. Yeah, I'll have to look up like urban heat island effects if there's actually been like research done on that. I have to get back to you on that.
Well, and I think one of the things that John is referencing is that in 2017 with the Globe Observer app, when we were collecting this data, we didn't have the land cover tool yet. So we didn't have that information about the data points that Brant was analyzing from the 2017 data. We didn't necessarily have land cover information at all. So one of the things that we're asking you to do, and we hope that all of you are going to go out at whether you're on the path of maximum eclipse or just on a partial eclipse, take a land cover observation along with your air temperature data, so we have that information, so we can maybe do some of that analysis that we didn't have the opportunity to do before.
Yes, that'll be extremely, extremely useful. So
Yeah, definitely. And John, that is a great question, because when Brant and I were working on the paper, one of the comments was all the different climates that people were at in the observations. So I'm thinking of Irvine Heat Island, but in a bigger scale, right? It went through desert and then through mountainous areas and then the beach and things like that. So definitely taking those observations are going to help us out a lot. So thank you for that question. Okay.
Stephen asks, have we observed any differences in temperature between an annular eclipse and a total eclipse?
So that's an interesting question, because it doesn't really show up so much in the data that annular eclipses and total eclipses are pretty. Again, there's variability between eclipses, right? But I haven't seen evidence that there's a substantial difference in the temperature measurements between annular and solar or total eclipses. You know, you're talking about a difference in sunlight of like 1% or something like that. Like there's like 1% sunlight available during an annular. So that's, you know, from like a meteorological perspective, that's basically no sunlight, right? But you do kind of, here I'm talking more anecdotally, my experiences. I saw the 2012 annular eclipse out in Utah, and you do, like, in person, you will feel a total eclipse in the way that you don't feel an annular eclipse. You know, annular eclipses are still neat, don't get me wrong, but you'll feel the sunlight disappearing during the total in a way, you know, on your skin is what I mean, you know, in a way that you won't quite feel during an annular, and you won't pick it up on an instrument. But hopefully that answers your question. From a meteorological perspective, there's very little difference.
Well, and just a follow up to that, because I believe, I'm not sure about the annular coming up in a week and a half, but I think for the total in April, the time period of the eclipse itself is longer for this one in 2024 than it was for the 2017 eclipse. And I think even by what's like a minute or two longer. I feel like the one in 2017 was fairly short, and I think this one has a longer duration. Brant, do you think that'll make any difference?
So I'm speculating here. I don't think that the length of totality or annularity is going to be the biggest factor. I think that other factors like cloud cover and the local climate and meteorological conditions or so on will probably be a bigger factor than the duration of totality or annularity. Although certainly from a human perspective, you want it to be longer.
Talking about the local conditions, I would imagine that the eclipse would have more of effect in the drier climates, correct? Where there's less heat capacity in the atmosphere because of all the moisture.
Less heat capacity combined with fewer clouds. Both of those come together to, in general, again, there's a lot of variability, but in general, you're right. Arid areas generally experience more of a temperature drop than wet areas.
Okay, so Zachary, go ahead and ask your question.
Absolutely. On October 14th, I plan on attending a annular solar eclipse event in Arlington, Texas. And just before that, I plan on signing up as a data collector after the webinar is finished. The event that I'm going to, would it be a good chance to collect any data to hopefully submit to the Eclipse Soundscapes website?
Okay, so yes, it will, but probably as the observer role. So that would be more of your recollections and your personal observations. For the data collector role, we're mainly advertising that now for the April 8th, 2024 eclipse. Quite frankly, it's too late to try to ship out a data collector kit to people in time for the annular eclipse. But, and MaryKay can correct me if I'm wrong, because I often am, but I believe the application process opens up for the 2024 data collector role on October 20th. And so if you're in the Texas area, you're lucky because you get both the annular eclipse in not this coming Saturday, but next Saturday. And then on April 8th, you have the total solar eclipse. So if you can't do the data collector role this time, we encourage you to apply for a kit for the next time. And again, we don't have enough kits so that everybody gets one. On our website, we have all the information that you need to be able to make your own kit and find the parts to be able to make your own kit if you want to do that. And again, we have all the other ways that you can participate other than data collector. So please participate in one way or another. And the observer role data is extremely important to us because one, that gives us context for the data collector role. So it gives us qualitative data that we can match with the quantitative data. And MaryKay, do you have anything else to add to that?
Yes. So I just wanted to point out the data collector role, as Trae mentioned, requires an AudioMoth device. So you either need to order it yourself or you can sign up to apply to get a free kit. So you don't have to sign up to get the free kit. You can also order one yourself. But you would need to allow for time for it to arrive to you from wherever you purchase it from, and then put it out 2 days before the eclipse. So because the eclipse is happening this weekend, you probably, even if you went online and ordered one, it probably, and by order, I mean purchased one, it probably wouldn't arrive to you in time to be able to put it out 2 days before the eclipse and then leave it out for those 2 days, the day of the eclipse and 2 days after. Because what that's doing is providing some baseline data, not just recording information from the day of the eclipse, but the days before and afterwards. But again, as Trae mentioned, if you want to do data collection for the total solar eclipse, you can either order an AudioMoth device and purchase one, and all of the parts, all the information is on eclipsesoundscapes.org. Or as Trae mentioned, you can apply to get a free kit. Those are limited in number, but those are 2 different ways that you can be a data collector.
And I will say, you can definitely use the Globe Observer Eclipse tool. Just get an air temperature thermometer, something that can either a digital one or your kind of basic liquid filled one. You can definitely do that between now and the day of the eclipse, because that requires less specialized equipment.
So I guess the most reasonable role to sign up for the 14th is as an observer.
Definitely.
All right, thanks.
So some other questions from the Q&A, and if somebody wants to ask their own question, you can let us know in the chat, or you can raise your hand. So from Aiden, has there been a difference in temperature from eclipses from 2017 to 2023? Has the temperature increased or decreased over the years?
Okay, could you repeat that question?
Yeah, so I think, and I guess I'm not sure if this question is a difference in temperature from eclipses between 2017 and 2023. Has the temperature increased or decreased over the years? But I think that's a different question about a temperature for the eclipses and actually overall temperature. And I'm not sure which way they're asking that question.
Yeah, I'm not quite sure I know how to answer that.
Yeah, well, and I think we do know, I mean, there is an overall average temperature for the globe that's calculated every year, and that temperature has in general been increasing, but there may not be enough eclipses there. I mean, there's basically one somewhere in the earth every year or two, but that's still not a lot of opportunities for collecting data specifically about eclipses. But we do collect a lot of data about the overall temperature of the earth, and those temperatures, the average temperature on the earth is unfortunately in general increasing. And that data is available from NASA online, certainly. Here's one from Marley. According to the background behind you, you have clouds and other things that are related to climate. Are you also someone who studies eclipses? If so, what are you observing during this annular eclipse?
Thank you so much, Aiden, for that question. And I'm glad that you noticed all my background. So I am the project scientist for the cloud observations that are sent through the GLOBE program. So that's why I'm excited about clouds. And I got to study eclipses when Brant joined our team in 2018. And I am going to make observations next Saturday, not this Saturday, but next Saturday in New Mexico using the Globe Observer app and really looking at the clouds, because for 2017, Aiden, I was in South Carolina. And I noticed how the clouds dissipated, which is a fancy way of saying that they kind of went away. But like Dr. Dodson said, they were cumulus clouds, these puffy clouds that you see here. And so I'm interested to see now to go to the desert, like John was mentioning, all these different types of climates, and seeing will there be clouds, which types of clouds then, and then what's going to happen during an annular eclipse. And then I'm hoping to be in Texas, maybe near you, Zachary, for the April eclipse. Again, another different climate than when I was in 2017. And then I can be like Holly and Teresa, where they were at a beach and then inland and see that difference in temperature, if there's any differences that I notice. So thank you so much, Aiden, for that question.
Well, and I was in Nebraska for the 2017 eclipse, and it was definitely cloudy for a lot of the day, and we were starting to get worried we weren't going to be able to see the corona during totality. And then we did have a clearing of the sky enough that we could actually see the corona. So that was definitely pretty exciting. So I see, okay, so we'll go with the question in the chat from Susan. Does anyone know of any good videos for younger children about an eclipse? I'm hunting because I teach science in lower school and haven't found anything so far. And that might be something.
Is there a NASA in a minute? Is there a NASA in a minute, Kristen? I'm looking for you also, Susan.
Was there one about eclipses? I'm not sure. I thought I saw MaryKay on mute for a minute, but I don't know if
by lower school, I'm assuming this person means younger than 4th grade. Is that a correct assumption?
That would seem reasonable. That may be, I'm gathering outside of the US, so not the term we normally use. But yeah, I would think, yeah. But I don't know if it means really young kids or like, like 5-year-old kindergartners or like the slightly older elementary kids, because that is going to be perhaps a little bit different in terms of what's going to be useful for those different ages. So maybe Susan can clarify that. Let's see. So some people are putting some suggestions of Space Place has some resources for younger students. That's spaceplace.nasa.gov. And then you can search for eclipses there. Some other suggestions for so the YouTube videos. So there might be there's a program called NASA Eclipse, not Eclipse, but like Eclipse as in video clips. Those might be some other possibilities. So hopefully, Susan, some of those things so pre-K to 5th grade. So it looks like pre-K, K, and 1st grade. So definitely on the younger side of that.
So I will throw out that the apprentice role in the Eclipse Soundscapes project, there's 8 lessons there that are about different elements of eclipses, and they do have little video clips for each of those. Mostly we say that the apprentice role is geared more towards middle school and older. However, there are some videos in a couple of different ones that you could possibly use for maybe 3rd or 4th grade. So it might be worth at least clicking through the apprentice role and some of the video clips that we have there to see if there is something that could be useful in some ways.
And although it's not videos, I do think that doing some of the kinesthetic learning for kids that age and getting, a light bulb or a yellow ball that represents the sun, and the kid can be the earth, and a ball and a stick to be the moon, and do some kinesthetic learning and sort of modeling some of the eclipses. I recognize that's not a video, but I think some of that can be very, very effective for some of those younger students as well. So I know we're at 8:45. We're trying not to keep you too long, but looks like we've got a couple of more questions in the Q&A. One from Mari asks, have earthquakes changed the path of the eclipse? And I can take an answer at this one. And the very short answer is no, because what is affecting the path of the eclipse is the geometry between the sun, the moon, and the earth. So that's not going to be something that's going to be affected by earthquakes or anything that happens on Earth. It has to do with the orbital paths and when the sun, moon, and Earth line up exactly right to have an eclipse. For example, the difference between an annular and a total solar eclipse having to do with whether the moon is a little bit further away, so it's not fully blocking all of the sun, the sun, sort of the face of the sun getting the corona. And then another one from the Q&A for Yasitha. how does NASA get the exact location of the eclipse, and how does that process work? Either Trae or Brant want to answer that, try to answer that one. I think the short answer is math, right?
Math. That's what I was going to say. Lots and lots of math. There is a page on, let's see, it used to be solarsystem.nasa.gov, but there was one person who calculated all of the eclipses and their paths for the next several hundred years. And eclipses are such a regular occurrence and so well understood that if you know how to calculate those, you can do them many years in advance. In fact, one of the first things that ancient astronomers did, when I say ancient, I mean like more than 1,000 years ago, in the days where they were building things like Stonehenge and these stone observatories, they were able to calculate eclipses because they happen on a fairly regular basis. So these are things that are well known. Unfortunately, I don't know all of the math, but simple geometry, and it's knowing how the moon orbits the Earth, because really you have to know when the moon is a little bit above what we call the plane of the ecliptic, right? And the plane of the ecliptic is basically a plane, like a flat sheet that the sun, Mercury, Venus, Earth, and the other planets pretty much all lie on. Sometimes we go a little bit above, sometimes we go a little bit below, but pretty much we're all on that same plane. And the moon also orbits about, but rotating around the Earth. And then again, sometimes it goes a little bit above and sometimes it goes a little bit below. So it's just figuring out when it's right on that plane of the ecliptic during a new moon. A new moon is, of course, when the moon is up in the daytime and it's, at the same time as the sun. So on the plane of the ecliptic, at the new moon, and when those two things happen, you can figure out about what time it is, and then you can plot out where the shadow is.
And I would add that another kind of interesting thing that was done for the 2017 eclipse, and I'll see if I can find the link quickly, but a visualizer, a scientific visualizer at Goddard Space Flight Center where I work, used some very detailed calculations and some of the more detailed mapping of the moon, and was able to use that information, because of course the moon is not a perfect sphere. It's not smooth. It has craters. It has rough spots. And so his name was Ernie Wright, and he actually used those precise mapping of the moon to figure out a much more precise eclipse shadow on the Earth, because again, that means if the moon isn't a perfect sphere, so that the shadow of the moon on the Earth isn't a perfect sphere. Plus, then of course you have the topography on the Earth, so the interaction between all of these irregular shapes meant that it's a kind of interesting shape on the Earth. And so that was some more interesting math related to exactly where is the totality going to be kind of at the edges, and that's from NASA Scientific Visualization Studio.
Also, too, I found the NASA site. It's not the new Eclipse site, but it's the old one. And so if you're interested in the math and how that's calculated, there's information there and information about the code that NASA used to actually do those calculations. So that's eclipse.gsfc.nasa.gov.
Oh, so the Globe website, observer.globe.gov/eclipse. is the one for the Eclipse page, specifically for the Globe Eclipse tool. Thank you so much for joining us this evening and for making this a nice interactive conversation with lots of questions. And we really appreciate you all coming out, and we hope that you enjoy observing the eclipse, either the annular coming up in a week and a half, or the total coming up in April, or both. Anything else you want to add, MaryKay?
No, just make observations, make notes, use AudioMoth, use the Globe Observer app. I'm going to have a little notebook to write down all these observations, because I felt the wind, but Brant didn't feel the wind for 2017. So I'm gonna keep very detailed notes, Brant, if I feel that wind for the one in next week. And so all those detailed notes that you can take are going to be extremely important. So like Eclipse Soundscapes says, experience the eclipse with all your senses. So thank you everybody for being here.
take down your latitude and longitude and what you hear or see in terms of insects and animals when you're taking those notes. And there are some notes handouts on the Eclipse Soundscapes website that you can download and have your own notes journal to be able to take those notes. So we definitely appreciate those.